Well, hey there team, and welcome to Stationeers. Well, hello there team, and welcome back to a bit more Stationeers, continuing along. And everything's going swimmingly. I'm going to just check this dish. What happened here? Someone said something about plugging it in. Okay, so I think there's a misunderstanding here. Well, that is plugged in. Oh, I see what you're saying. That part's not plugged in. Of course, wonderful. Good point. Wonderful point. I thought people were going to say that that this wasn't part of the grid. Now I don't want to make assumptions because they've made a very, it does seem that I don't actually have any power draw coming from the new setup, but now I do, which is wonderful, right? But it's kind of important for redundancy theory to keep them separate, at least in the way that I want to construct it. And it is interesting. I wonder if people understand that. I don't think that's something that's super common knowledge. Redundancy means getting sacked, usually, for a lot of people. Anyway, let's just make sure that this is all hunky-dory. That's good. Everything's wired in. That's fine. That's the data in. That's the power out. Power's going into our power controller, which is full as anything. And that's just taking power, and that's fine. Okay, cool. And then this seems to be tracking the sun at a pretty good efficiency. Again, we discussed the adjusting it. Look, see, it approaches 100% as it reaches the peak of its cycle. It's good enough, in my opinion, especially since all we really have is one power converter, and we don't have the capacity to make larger batteries. We're sort of on the edge here. Now, fortunately, I'll be able to do something like switch out this battery here. And that should charge super fast now because it's basically got the two things going on there. I'll just really quickly say, the whole idea of redundancy is, like, it improves net efficiency in theory, but we don't exactly have wear cycles. It's not like, so consider the nuts and bolts that make this thing move back and forth tracking the sun, or that one, right? Eventually it would break in real life. And there's a whole subset section of engineering about that, about how it wears out. That's not simulated in the game, as I believe. But there's another point that I don't think a lot of people really consider, and it's that you need to have a healthy respect for the fact that you're not as smart as you think you are. I'm not pointing at you. I'm saying this is how I govern myself, right? So if I put in a cool system and I think it's really clever, there is a very real chance that there is a flaw in that, or that I will do something later on that will overlook that and make a mistake, but it may well be my own fault. So the point of having a redundant system in that case, which is this world, is that if I stuff up the logic unit, for example, the battery's not big enough in there. Like, we identified that it's probably going to go flat overnight. But say that system breaks because I overlooked something, maybe I put too much power through a wire and blew it up or something, you have a backup system. And to be if I'd be really comfortable with 2 levels of redundancy, to be honest, so have a backup to that backup as well. But so that's something that I would do for my sandboxing in this, is I would build these sort of systems. Maybe that's a perspective not everybody thinks of, because I don't know if that's sort of common practice. But yeah, that's how I look at it. I go, right, I'm clever. I've come up with this logic unit. I've explained it. That's great. But there's a very real chance, like, that you haven't plugged the power in, right? You make mistakes. You're human. It makes sense to create systems to back up against your own stupidity. Anyway, so I'm going to cook a tato. And then we're going to get this show on the road. Clear microwave? No. Close microwave. It's going to be nighttime soon, because remember we went a little bit longer last episode just to sort of showcase that we've got power. But basically we've got enough power, honestly, for the grid for the moment. I saw someone saying, crying out loud, wire the doors in. You might want to run the numbers on that. The passive draw of the doors. Someone came before you in the comments and said that you should wire it in. And, oh look, I'm not allowed to overeat. Interesting, we'll hold on to that. The passive draw is nuts, and given that our entire capacity of our grid, now that I've split the power controllers, is literally just one large battery, I wouldn't be surprised if those 2 doors on their own, let alone the 4 doors, could flatten the entire grid with passive draw. It's possible. The fact that it is possible, and I don't know for sure, is a good enough reason not to wire them in. So we're going to have to wait until we shore it up. Sorry, I just like to cover the stuff that, you guys bring up interesting points it's worth covering. So the next big step, team, is the furnace, right? So I'm bloody terrified of this because I am in no way a furnace expert. I'm doing my due diligence and my best to understand it, but there is a very real chance that I will blow myself up. Now, I'm not 100% sure where we make it from. Let's have a look. All right, so the arc furnace is what we've already got. How come there's 2 different furnace kits? Well, iron and copper, that is not a small amount. 30 and 10. Alright, so first thing we want to do is get this show on the road. I probably don't have enough juice for that. Oh, look at that. I'm just short on the ore. And copper, we're good. Oh, a tiny little bit of ore would do me. Oh, do we have any nearby before this sun goes down that I could just sneak? Christ, look at that valley right next to my base. I'm gonna fall in that. You know it. Let's not fight it. Come, quick. I don't think we're gonna eyeball some. There's some copper. That doesn't help us though. Alright, so we're gonna have to do a mining run. That's okay. That's fine. We'll cook all this up. We'll do our evening rounds. We'll get in the door with me big fat head. Alright. We'll cook this, that's quicker. Alright, so things are going along fairly swimmingly. So we'll build the furnace. And what's to say? Without a furnace set up in front of me, it's tough to sort of talk about. I think maybe one of the first rookie things a lot of people do, or at least that I did in the early days, I think the back end of the furnace, because there is essentially an exhaust port for the furnace, right? Geez, that was quick. There's an exhaust port for the furnace, and you put like maybe a passive vent on that or something like that, which will just create free flow. So as soon as you start putting things into the furnace, let alone starting the furnace, as soon as you start pumping gases into the in thing before you even prime it, a lot of it's going to flow out the back. So you need to actually have like a valve on the back or an active vent. I don't know about the active vent sort of thing, but I think a valve probably makes sense. And that way you just trap all the gas in there. Because if you're doing everything properly, that's sort of what you want to do. Oh, 11, that's pretty perfect. I'll turn that off for the moment. Yeah, so that doesn't reset. Or does it? No, the dish just stays that way. Okay, that's cool. Yeah, and see, like, even just using then, I've drawn down the grid anyway, so I don't think we would want to wire the doors yet. Not until we've got a second power controller. I just don't think that's sensible. Because we'll end up in that scenario where I'm stuck in an airlock without power and lose atmosphere sort of thing. Alright, so we still need another 5 iron. Alright, so I'll just do my rounds real quick. And we'll finish off this so it's out of the way. And then we'll go looking for some iron potentially in the dark. I mean, not the best setup, but so be it. But we're getting there, team. Alright, how's this gonna feel in here? 30 degrees. That's okay. Yeah, I'm curious what that spike was. It must have been a reaction to what I did with the CO2. Because it was just a one and done, and it seems to have cleared itself out. Alright. And as discussed, I'm just going to keep doing this until we run into a problem, like a catastrophe. Because if this system breaks, at least it'll break and I have a bazillion potatoes. You know, so it makes sense to use it now. while we've got it. Okay. Oh god, I'm getting squished up here. Okay. Alright, let's not mess this up again. We want to go set outward. And we'll give it a quick squirt. Yeah. Little squirty squirt. Set inward. Yeah. There we go. I know it's fiddly, but hey, it's a good system. It works. It doesn't require steel. Like, this is a fantastic starting system. We will just squirt a little bit more. Yeah, there we go. That's perfect. I'm happy with that. System's going to be pretty happy with that. Very good. Might as well check it. It doesn't hurt to just have a quick squeeze. Yeah, 1%, 1 mole of CO2 in here, which is not bad. That's fine, you know. We'll, I mean, like, there's an errant little bit of X in there, but it doesn't seem to be causing any trouble. Again, this isn't a final form. We will build another one later on. Okay, cool. So that's fine. Done, done, done. Becoming quite used to this little base, you know. Alright, so the question is, does it have a battery in it? That wasn't the question, but we might as well go. Let's go mining, night mining. Let's do it. Have I got the tracker cartridge? I do. You know I hate doing this. But, Jesus Christ. It's more about breaking your neck, actually. Let's just try and start this high ground, eh? So the furnace, I think the part that where people fall over with the furnace is getting a good burn from a good mixture. It's all good and well telling people that there are good ratios. I'd have to look them up. I don't have it off the top of my head. But I believe it's something like... oh, Jesus Christ. It's a 2-to-1 scenario. Do we have any volatiles at all, actually? I don't think we do. That's another thing we're going to have to do. So, lucky I found some. We'll grab this, because we're going to need this for our furnace fuel. Trying to get a pretty good, efficient burn is, you know, ideal. So you sort of... And mixing before you put it into the furnace, I think, is the trick, right? Once you figure that out and you've got a system that can do that, then you're pretty good. I think the whole issue is there is a pipe thing, like I don't know what you call it, because it behaves like a pump. It's like a mixer. It's a fuel mixer. So you can put in your oxide and you can put your volatile in. You know, we might as well, if there's more here, we might as well just grab it. And it's supposed to mix them in, but all it does is it just keeps... I'm not 100% across how this particular pump thing works. But it doesn't work, I think, as a lot of people intuit and intend. It doesn't just fix your problem. Because there is a fair decent chance that you are pumping potentially different volumes of, let's say, liquid. Oh, look, there's way more over there. It's not really... It's a gas, but you know what I mean. You're pumping different volumes of this gas of oxide and volatile through the pipe at different densities, different temperatures, and it's trying to do, like, I don't know, what are you doing, like a 2/3 split, like a 66 to 33? I'm not 100%... Ice! Ice! We'll grab that, because I was almost convinced this shit didn't exist. Oh well. Maybe it doesn't. Maybe it's just 8 ore on my planet and that's it. Oh well. Yeah, so getting a sort of thorough mix is the sort of tough thing. So I think you can probably, now again, this is a lot of theory going to be putting into practice. I think you could probably just load up small little sections of pipe with like well, not using a back pressure. Ah, here we go. But you could probably use a pressure valve for like a pre-made section of length to try and get some even distribution, and then you could seal that. So now you have essentially, let's call it a small quantity by being a length of pipe or whatever. And you can let only X through into that tiny little thing. So it's almost like making a mini container of the amount of gas that you want, and then you could pump them forward and let them mix. Like, you could just put them into the same pipe section, right? They should mix, as long as, you know, make sure there's enough pipe that they don't explode or anything like that. And then you should be able to just almost inject that in, just shoot that in. So it'll be a lot of valves cordoning off your little mixtures, but essentially you're trying to make this like a hot shot of the right mixture, and then you just inject it into the furnace, I guess. That's sort of where my mind is at, because you're sort of trying to juggle the systems of how this video game handles it as well. And then from there you could, I don't know, you could mess around with how much you need to go in. Like, everyone talks about the ratio, but you could also, you could try and be as stingy as possible on the actual amount, you know, the actual mole of gas that you use. So you could potentially have the most efficient burn possible. All right, do we have any idea where this base is? Nah, that's okay. We can do this. I hate doing this, but alright. Charge is critical on this battery. That's not great. Tracker. No, just turn on, please. There you go. Oh, look. The sun's starting to show us the way anyway. Look, there it is. So we can just turn that off. Well, that worked out. Alright, so we've got some iron. The other thing, I think that's silicon. Could be ice. Not that worried just yet. Oh, look, there's some iron we ran straight past. Perfect. But we've got enough for the moment, so we're all good. Oh, hang on, what's going on here? That's just a little dip. Look at this. Look at this sheer bloody hole. Mark my words, that's how I die. Alright. This will be good. Alright, let's put you in there. Turn you off. I guess it doesn't really matter. Well, look, that's tracking. How's the battery looking? That's interesting. We will have to observe it at one point, because I could have sworn it went flat overnight and then it ended its cycle over there. You know? Potentially it gets a little charge from this. No, that's generating nothing, so it definitely didn't get charged from that. So what's happened here? Maybe it held enough charge overnight to do it. We're gonna have to observe it at some point. See what's going on. Or just don't pull the friggin' volatile out and we'll be alright. We only needed like 5 or something like that, didn't we? So we're good. Nice. So let's bung this in the old cooker. Furnace, right? So that should be it. there was another... I think there's another furnace beyond this one, but I have no idea about that. That's not me. Alright, that's going to take a little while. So where are we going to set it up? It sort of floats. It doesn't really fix onto the ground. To be perfectly honest, if we can put it away from our everything, that's probably a good idea. Well, let's have a think. The other thing is, we've got to realize there's a lot of spark works here. Even though we're in vacuum, we do, look at this, we blow a lot of errant, you know, gas out there. So if anything, like working out here would be the money, I think. We might actually start a new little satellite place here. It'll be a little bit of stuffing around because we're going to have to run pipes back and all that, but I think that's probably safest. And if it did detonate, I don't want it near my base. We'll give it a little bit of clearance. Alright, so we're probably going to want to build a few more iron sheets, or whatever you want to call it, iron frames and such. So let's cook up some of this. Oh. And how are our filters looking? 60, 100, 100%. That's alright. I think that's a good thing. Can't remember if 100 or 0 is good. Probably should remember that. Alright. That's probably enough. Oh. What's going on here? 83. Oh, Jesus. Alright, cool. Now, oh, someone was also asking about having multiple of these. So, this becomes easily repeatable. You just need what's called a batch writer. So at the moment we've got, it just writes the one logic line. Now, I am rusty, so correct me if I'm wrong, but I at least understand the theory, so I'd be able to figure it out. Either you would replace that whole cloth with a batch writer, or you send the signal from the logic writer to the batch, and then you send the batch out. Right? But essentially you can create it so this whole setup sends the same signal that can be used by multiple things. So you could have an entire solar farm running off of one thing that that sends that line. But then again, like, you know, what happens if your batch writer blows up? What if one of these cords, what if we send too much power through here and we surge and we blow it up, and because it's all sharing data and power lines, bang, your entire solar grid of 20 solar panels being batch written now don't receive commands. It just gets back to that sort of redundancy theory, that's all. Oh, look at that. Alright, nice. Let us go frame. Iron frame. We'll build a couple of these. Yeah, one more will do for the moment. Alright, let's go. Oops. I guess he's coming with us. Hang on. Go down. I am still pretty married to the idea of doing this behind the base. Let's probably do it there, because that's not really coming up high enough. Yeah, let's do it like this. Boom. Pop that there. Pop that there. Let's pop another one there. And then, I don't know, maybe we'll put the furnace sort of like that. We will just let it float, because you can't really brick it in at this point, especially when we're doing sort of an open build as well. We're trying to explain how it all works. Yeah, that might be the best way to do it, like that. Bit weird, I know, but hey, I didn't make the game. All right, and we've got to piss fart around and build it up in the several stages. We need iron sheets and a wrench. It's gonna be a bit of running back and forth here. I know I'm pretty sure I'm gonna need plastic sheets. Come on, you fathead. All right. Sheet. 1, 2. We're going to need them for the floor as well, but let's just get this built for starters, because that's what That's what we're all here for, you know? Alright. So, what was it? Wrench. Oh, welding torch and two more iron sheets, my bad. Okay. Okay. Lucky we cooked a bit of iron first. We'll get this on the job. Chill, love. Angle grinder to deconstruct. No, okay. Are you finished? Is that what you're telling me? It looks finished. Guess you don't need plastic sheets. We'll go switch the battery now while we've got the warning, just because that tracking will be able to cover it just fine. Look at that. So yeah, we're keeping our current capacity really, really well topped up, but it's not big enough for me. One power controller with one battery? Nah. I think you can build static batteries as well, like an actual, like a building basically. And we'll look at that later. I'm assuming that they require steel actually, but they might not. I might be wrong. All right, let's go over this furnace real quick while we've got it here. All right, so essentially, you've got your in and your out. So this is where your materials go through into there, right? And if you're cheeky, you can put your what do you call them? Your ice straight in there. Obviously at night time it'll melt if you do it here. It'll sublimate basically. And then this is like a chute for your cast, right? And out the back, the other things we have are as output and input, right? So the theory goes that you create a fuel mixture to go in. The developers have said that there are all sorts of different mixtures for different things, which makes sense. The 2-to-1 idea of oxide and volatile is just about having a clean, efficient burn, right? So no waste or anything like that. But that does not necessarily mean for the amount that you use that you're necessarily going to get the high pressure burn that you need for like a more advanced super alloy. But again, I'm talking out my ass at this point because I don't have those numbers in front of me and I'm not interested. I'm only interested in steel, right? So essentially, you input your perfect gas mixture into there, right? And then you have an exhaust here. You want to kind of block that while you're using the whole thing because, well, if you have a passive vent on the end, it will just flow through because that's how a passive vent behaves, right? And a lot of people put them on the end. So you need some sort of stopper on the end. This behaves like the eject on any of the other bits and bobs that we have, right? So it pulls that out, but essentially it's a mold release. So we're baking in there. And then you've got your ignition here, right? And it reads out your pressure and your temperature. So you can get an idea of what's going on there. So that's how it sort of works is you prepare your mixture, you know, valve it off, pipe it off, you shoot it in, you make sure the back end's sealed before you do that, sorry. Then you have your mixture in here sitting there, you're comfortable, you're happy with that. You hit the bloody go button, and bang, and then it should jump. It'll create the, you know, essentially the ignition inside there. And then you'll have a burn. It should be bright blue, I guess, depending. And then, I mean, you can drop your stuff in there in the top, I suppose. I don't think there's any harm in dropping it in after the fact. Like, get your burn working and then add your material in. You can see it's just an in chute that you pop straight in and it just eats it. Sort of like the in chutes on the auto lathe and all that sort of stuff, right? It's kind of a safe door, right? Now, one thing I've been wondering about, and because obviously we're not really going to get into it today, is can you have like a sort of a reverse reaction out of this pipe? In my testing, it seemed like you can't. My concern is, so say you have your fuel mix all the way up into here without a valve. So it's one of our normal yellow pipes up to here, and it's holding the fuel mix in there. Is there a chance that the ignition in here can backwash, you know, can flush back up the input pipe and just detonate frigging everything? I'm not certain, but I'm terrified of that. But I did a little bit of practice, and it seemed like it wouldn't. It actually seems like there is a hard stop between the two. Well, actually, no, I shouldn't say that. It seemed like there's a one-way valve. So if you did that, it's not going to go back, but it does actually seem like your gas, if it's allowed to, will just keep feeding in, which is yet another problem, because then this will just get hotter and hotter and hotter, and eventually it'll frigging explode, right? Something will give. Potentially it'll explode out the output, I actually think. I think it might blow up the pipe on the output, but not necessarily the input. I don't really know where it ruptures. But anyway, okay, so that's it. That's the general idea of what we're going to do. And then you'll put in your mixture of metals depending on the alloy that you're making, because we're making steel, and we're just doing it like an iron, carbon compound there. So we're going to put coal in there. It's a bit simplified, but it does the job. So you put coal and you put iron in there at the right ratio. I think it's a 3-to-1, something like that. I'd have to double check all that for the next episode. And then we pipe out here. There's another couple of things as well you got to consider. Oxygen. What are we going to do with that? Where are we going to get that from? Well, we have our supply, right? So we're probably going to just use that to get the thing rolling. But that is another consideration. As soon as we start plugging that onto our network, what happens if it blows up and we blow up all our oxygen? That's a bit scary too. So maybe we'll come up with some sort of separation system. Maybe we draw a canister of oxygen out of the supply and then put it into a canister feed over here. So at least if it all goes shit sideways, we don't blow up our oxygen back there. And then the other thing is volatiles. Volatiles are actually easier to get into the system than you might realize. Essentially, we're going to get one of those oxygen tanks on a floor thing, and you can put an active vent on the floor, and during the daylight, because it automatically sort of just melts in the sun, you could turn the active vent on, and you can sit the ice on the vent, and it will just suck the gas form volatile straight in and fill up the tank. I've done this before. It seems like the easiest way to do it for me without requiring doing it in a room or something like that, because the last thing you really want to do is start putting volatiles inside your base if you can help it. Anyway, team, lots of questions, lots of pointers. They will be welcome because this is another chapter in our little base. But I'm pretty excited to sort of do this next part. All right, might just leave it there and I'll catch you guys on the next one.